Welcome back. We are beginning with the second part of our topic, graph of quadratic functions. In this video, we are going to learn how to draw the graph of a quadratic function. Before we do that, let's refresh our memories on how to draw the graph of a linear function. Graph of linear functions. In the videos on straight lines, we learned how to draw the graph of a linear function. In that video, we learned that if you want to draw the graph of a linear function like y is equal to x minus 1, we will need at least 2 points that fall on this line. To find those 2 points, we will first assume a value for x. Then, we will substitute that value into this function to get the corresponding value for y. We will then assume another value for x and substitute it into the function to get the corresponding value for y. With those two values, we can plot them on our graph sheet and draw the graph of the linear function. So let's say that the first value we assume for x is 2, when x is equal to 2. Now we have x is equal to 2. We can substitute it into this function to get the value for y. When x is equal to 2, y will be equal to 2 minus 1 because x is now 2. So y is equal to 2 minus 1. And 2 minus 1 will give us 1. This means that when x is equal to 2, y is equal to 1. So after the first assumption, 1 point that falls on this line is 2, 1. We will need another point because to draw the graph of a linear function, we will need at least 2 points that fall on the line. So let's assume another value for x. When x is equal to 3, we will then substitute this value into the function to get the value for y. When x is equal to 3, y is equal to 3 minus 1. 3 minus 1 will give us 2. This means that when x is equal to 3, y is equal to 2. So we have the second point, 3, 2. Now, we have 2 points that fall on the line. We can plot them on a graph sheet in order to draw the graph of this linear function. So let's say that this is our graph sheet. We have our x-axis here and our y-axis here. We will plot the first point. The first point is 2, 1. So we will look for 2 on the x-axis. We will look for 1 on the y-axis. 2 and 1 will meet at this point. So that is point A, 2, 1. We will plot the second point, 3, 2. So we will look for 3 on the x-axis, then 2 on the y-axis. 3 and 2 will meet at this point. We will call that point point B, and the coordinate is 3, 2. With these 2 points, we can draw the graph of this linear function y is equal to x minus 1. When we assume another value for x and substitute it into this equation to get the corresponding value for y and plot it on this graph sheet, we will see that that point will fall on the straight line. So in actual sense, you will need only 2 points to draw the graph of this linear function, because if we find more points with this equation and plot them on this graph sheet, we will see that they will all be on the straight line. As we can see here, the graph of a linear function is a straight line. So when you draw the graph of a linear function, you are going to have a straight line. Now that we have refreshed our memories on how to draw the graph of a linear function, let's learn how to draw the graph of a quadratic function. Graph of quadratic functions. The graph of a quadratic function is a curve. From the previous slide, we saw that the graph of a linear function is a straight line. So when you draw the graph of a linear function, you are going to get a straight line. When you draw the graph of a quadratic function, you are going to get a curve. In this topic, the graphs of quadratic functions that we'll be drawing will look like this. So it will look like this, or it will look like this. So this is how our curve will look like. It will either have a U shape or an N shape. Because the graph of a quadratic function is a curve, we can see that you will need more than 2 points to draw the graph of a quadratic function. Let's consider this example. It will help you understand this better. Let's say that this is our graph sheet. We have one point here and we have another point here. If these 2 points are points that fall on a straight line, we can easily join them to get the graph of the straight line, because we know that all the other points will also fall on this line. But if these 2 points are points that fall on a quadratic curve, it will not be that easy, because as you have seen here, the shape will be like this or like this. Now, how will you determine the shape of this quadratic curve with just 2 points? It will be difficult, because our curve can look like this or it can look like this. So as you can see from this illustration, 2 points will not be enough to draw the graph of a quadratic function, because with only 2 points, it will be difficult to determine whether our curve looks like this or it looks like this. So clearly, to draw the graph of a quadratic function, you will need more than 2 points. Because of this, when you are asked to draw the graph of a quadratic function, let's say that we are given this quadratic function, y is equal to x squared plus 2x minus 3, and you are asked to draw the graph of this quadratic function, usually you will be given a set of x values in a table. So like this table that we have here, the set of x values we have are -2, -1, 0, 1, 2, 3, 4. What you do is that you substitute each one of these x values into the quadratic function to get the corresponding y value. So you begin with the first one, when x is equal to -2. Then you will substitute x is equal to -2 into this quadratic function to get the corresponding y value. So when you do that, you have y is equal to, x is now -2, so -2 squared plus 2 times -2, or 2 into bracket -2 minus 3. And this will give us -3. So it means that when x is equal to -2, y is equal to -3. So we have our first y value. When x is equal to -2, y is equal to -3. Then you move on to the next x value. The next x value is -1. So when x is equal to -1, you substitute this x value into the function again. So you have y is equal to -1 squared plus 2 times -1 minus 3. And this will give us -4. So when x is equal to -1, y is equal to -4. So we have our second y value. When x is equal to -1, y is equal to -4. So you do the same for all the x values. You find y for when x is equal to 0, you find y for when x is equal to 1, you find y for when x is equal to 2, you find y for when x is equal to 3, and you find y for when x is equal to 4. So you can see that you have a lot of points to plot on the graph sheet. This will help you to get a clear picture of the shape of the curve. So in this case, we will have 7 pairs of points. We will have 1, 2, 3, 4, 5, 6, 7. So we will have 7 points to plot on the graph sheet. So after finding the y value for each one of them, let's say this is our graph sheet, you plot the first point, you plot the second point, you plot the third point, you plot the fourth point, you plot the fifth point, you plot the sixth point, then you plot the seventh point. With these 7 points, we can see a clear pattern. we can see that the shape of the graph looks like this. Okay, so now that we know the shape of the graph, what you do is that you are going to join the points with your free hand. Now, this is very important. You join it with your free hand. This means that you will not join the points with a ruler. You are going to join them with your free hand. So you join the points with your free hand, and in this case, our curve looks like this. So after finding the y value for each of these x values, you plot them on a graph sheet, then you join the points with your free hand to get the graph of the quadratic function. As we have seen, the graph of quadratic functions that we'll be drawing in this topic will look like this, that is the U shape, or like this, that is the N shape. When will you get a U shape and when will you get an N shape? You will get a U shape when the coefficient of the quadratic term is positive. In the previous videos, we have learned that in a quadratic function, the quadratic term is the squared term. So when the coefficient of the squared term is positive, the graph of the quadratic function will look like this. Conversely, if the coefficient of the squared term is negative, the graph of the quadratic term will look like this. So if the coefficient of the squared term is positive, the graph of the quadratic function will have a U shape. If the coefficient of the squared term is negative, the graph of the quadratic function will have an N shape. So for example, the graph of the function y is equal to x squared plus 2x minus 3 will look like this because the coefficient of x squared here is 1, which is positive. In the same way, the graph of this quadratic function y is equal to 3x squared minus 5x will look like this because the coefficient of the quadratic term is 3, which is positive. If we consider this example, y is equal to minus 2x squared plus 7x plus 4, we can see that the coefficient of the quadratic term is negative 2. Because the coefficient of the quadratic term is negative, the graph of the quadratic function will have an N shape. Here is another example. Y is equal to 4 minus 5x squared. The coefficient of the quadratic term is minus 5. It is negative. So the graph of the quadratic function will have an N shape. Thank you for watching this video. Subscribe to this channel for more videos. We have learned how to draw the graph of a quadratic function on a graph sheet. So in the subsequent videos, we are going to apply what we have studied in this video to solve some questions. But before we do that, we first have to learn how to use a graph sheet. So in the next video, we are going to learn how to use a graph sheet. Bye-bye.